Hello students, welcome to the next lecture of the testing of the hypothesis. In the last lecture we had seen how to calculate the t, that is the t distribution for the students t test for small size groups. Today we will go further and we will actually find out or actually test the significance. So we will test the significance. Now let's see the working rule for testing the significance. To calculate the significance of a sample mean at 5% level, what we need to do is we need to calculate this t that we had already done into the previous lecture. We had seen how we can calculate the t, and then we will find out the standard value of the t. So we will find out the standard value of the t. So we'll find out the standard value of t, and then we'll compare these two values. So we'll compare these two values, that is the standard value and the tabulated or our calculated value. So if the calculated value, as we can see, if the calculated value is lesser than the standard value, then we will accept the hypothesis. Or in the other case, if this is greater than, then we will obviously reject the hypothesis. So this is the working rule. So let's move and obviously these standard values depend on the level of significance, at what percent level of significance is given. It could be the 1% level of significance, it could be the 5% level of significance. So as it is 1% level of significance, could have been at 5% and could have been at different percents. So we will need to get the standard values of those. Let's see an example here and try to solve it. In this example, we would be finding out the value of t. Then we would be comparing that t with the standard value of t distribution, and then we will decide whether to accept or reject the hypothesis. So let's understand this question. A manufacturer intends that his electric bulbs have a life of 1000 hours. He tests a sample of 20 bulbs drawn at random from a batch and discovers that the mean life cycle of the sample bulb is 990 hours with a standard deviation of 22 hours. Does this signify that the batch is not up to the standard? So now let's first try to understand the question. If we will able to understand the question, it will be easier for us to solve it. So let's understand the question. What are the values? So if we'll see that a manufacturer intends that his electric bulbs have a life cycle of 1000 hours, right? So this is the intended life cycle of the bulbs. Now he took a sample of 20 bulbs. So sample size, we have got the sample size, this is 20 bulbs. And from that sample size he found the mean life cycles is this 999 hours, so 990 hours. So this is the mean that has been calculated. So the calculated mean of the sample, and the mean of the universe is been given this. A standard deviation has already been given of the sample. So this is the standard deviation. Now let us understand where is the hypothesis. So in the last section, if you will see the last section, does this signify that the batch of bulbs is not up to the standard? So this is the hypothesis. Hypothesis saying that the batch is not up to the standard. Obviously, if we'll see the data, then it may arise in our mind that the life cycle of the bulbs was 1000 and the sample we have chosen, their mean life cycle comes to be 990, which is lesser than 1000. So it can come into our mind that the sample is not according to the standard. So now let's test this hypothesis. So what is the hypothesis? That this signify that the selected batch is not up to the standard. So now let's go and calculate the t, as we had already identified all the values, all the parameters for the calculation of t. So let's see the calculation of t, as we had already discussed that the mean of the sample is 990, standard deviation 22, and this is universe is 1000. So we'll substitute all these values into the question and we will calculate the value as 2.033. Right, we can also see this graph. So this is 2.033. Now we need to note one more thing: a given data, that is the level of significance, that is the standard value. So we should have the standard value from which we are going to compare the calculated value. Let's go back to the question and see the note that the value of t at 1% level of significance with 19 degree of freedom is given as 2.539. So what are these two things? 1% level of significance with 19 degrees. So 19 degrees, obviously, because we have a sample of 20, so the level, the degree of freedom has to be 19, one lesser than the sample size, and this is 1% level. The standard value is given at 1% level of significance. So we need to compare R value with this 2.539. So let's go and compare the calculated value, that is t is 2.032. The calculated value is lesser than, so we can see the calculated value is lesser than the standard value. The calculated value is lesser than the standard value, hence it is not correct to say that the batch is not up to the standard. So we will say that it is not correct to say that the batch is not up to the standard. So we have we had the hypothesis, and depending upon the comparative analysis, we will say that it is not correct to say that the batch is not up to the standard. So the batch may be up to the standard. So now let's try to understand another example. 10 individuals are chosen at random from a population and their heights are given in these manners. Now discuss the suggestion that the mean of the height of universe is 63. So this is the first purpose of the t we had already identified into the purposes of t distribution in the last lecture. So we need to identify whether this assumption is true or false. We will say that for 9 degree of freedom at 5% level of significance, the t value is 2.262. So we will have to see this. We'll have to compare our t value, which we are going to calculate, with this standard t value, and based on that we will either accept or reject the hypothesis. Now where the hypothesis is, let us identify the hypothesis. The hypothesis is that the mean of the given data of the given universe is 63. So this is the hypothesis that the mean of the given universe is 63. So whether we will accept this hypothesis, we will say that yes, the mean is 63, that means we are accepting the hypothesis, and if we will say no, it is not necessary, that means we are rejecting the hypothesis. So let's see our hypothesis is accepted or rejected here. For that we need the parameters to calculate the t. We know what parameters are required for us. We need the mean value, we need the standard deviation. So we will calculate these values. We will calculate the mean value. We had already seen how to calculate the mean value of the data. So here the mean value of the data comes to be 67, and similarly we will calculate the standard deviation. So standard deviation for the given data comes to be 3.13. So you must be aware how to calculate the mean and the standard deviation for the given tabulated data. Now with the help of these two, we will calculate the value of t. So this t value comes to be 2.02. So this is 2.02. We can see the normal curve, the region of acceptance, right? So what is the result, what is the conclusion? We can see that our calculated value is lesser than the standard value. Whence the it is standard value, so the hypothesis, so what we'll say, the hypothesis accepted that the mean of height universe is 65 inches. So the hypothesis is accepted. Whenever it is lesser than the standard value, we always accept the hypothesis. So we always accept the hypothesis. That means we'll accept that the mean of the universe is 65. So this was the hypothesis, and we have accepted the hypothesis. According to our calculation, the t comes to be lesser than the standard t. So we accepted the hypothesis. Let's understand one more question. This is the question given. The mean lifetime of sample of 100 fluorescent light bulbs produced by a company is compared to be 1570 hours with a standard deviation of 120 hours. The company claims that the average life of the bulbs produced by it is 1600 hours, 1600 hours. Now, using the level significance of 0.05, the claim is acceptable or not. Is the claim acceptable or not? So, again we'll have to identify the significance of the mean is being given or not. So let's identify what the things are given into the data. Just by understanding the question, we can see that the mean of the sample is 1570. So this is 1570. This is the mean of the sample. Standard deviation is given 120. So this is the standard deviation given into the question. Sample size n is given 100, so a sample of 100, and the mean of the universe, so mean of the universe, this is 1600. So all the values are easily identified. We had seen the values and we had calculated the value as 2.5. Now the question is, where is the standard value of t? Where is the standard value of t? So they have not given any standard value of t. If you remember in the previous lecture, whenever we had started the discussion of t distribution, we had seen two standard values, one at 5% level of significance, that is at 0.05% level of significance, and one at 1% level of significance. So there we had seen the normal curve. The standard value was given was t is equal to 1.96. You can go back to the previous lecture and can see that this at 0.05 the level of significance t was 1.96. So we have to remember this standard value. In many calculations, in many questions it will be given. So now just comparing this standard value and our calculated value. Now this is the first time we have got the claim we have got the calculated value greater than the standard value. So in that case we will reject the hypothesis. So simply the claim is to be rejected. The hypothesis was rejected. So I hope you have understood. Please replay the video again and again and try to understand the concepts of tree distribution. That's it for the day. Feel free to comment and ask your questions, and that's it for the day. Thank you so much.